Good morning. Say something in the chat if you can hear me. I've heard there's a 15-second delay on these. Oop. I have never done a Google Hangouts on air live before, and I've never done one with two monitors, so this will be a little bit of an experiment this morning. I'm going to wait for people to come into the chat here. All right, so instead of seeing me, you'll see some code most of the time here. Who has done for loops before, or range, or enumerate, or list comprehensions? I'm going to write those in the chat here. You can just say which ones you've done, if any. And I'm going to use that for reference as we're going through today. So I'm going to wait a few minutes just to kind of wait for people to come into the remote chat here. And I'll write some code while we're getting started. All right, great. Thanks for all the feedback on which ones you've done there. So there is a URL that we're going to be referencing for exercises, which I will put up in a bit. I'm going to throw it in the chat right now, though, just so you have reference for it later. All right, we won't be using that yet, but we will be using that for some exercises in a bit. So let's say we have a for loop, and we have a list that we're iterating over, and we're trying to make a new list out of it, and we're doing some kind of mutation to each of the things in that list. We know how to do this with a for loop, or if you don't know how to do it with a for loop, here's one way you could do it. You have your original list, my favorite numbers. You have a new list, doubled numbers, and you loop through each of them, multiply each of them by 2, and then append them to that new list. So list comprehensions are basically a way to take this formula of we have a list, we have a new list, we want to do something, and put those things from the old list into the new list. All right, now let me bring up a visual here. You can find the same visual on the link that I posted into the chat. Got to change my screen sharing here to bring this up, though. Just a moment. Okay, so let's back here. Oops, a little bit too big. Okay. So a list comprehension takes the original list And that's in purple there. You see for n in my favorite numbers, we're looping over that part. We just take that part we're looping over and we stick it at the end of this new list that we're making. And then we take the thing that we're actually doing, the n times 2, and we put it in the beginning. And the list that we're actually putting these all into go on the left side of the equal sign there as usual. So that's pretty much the basics of a list comprehension. In a moment, we're going to see this one too. If you're in this document, feel free to scroll down and jump ahead though. If we have a conditional, that goes right here too. And these are pretty much the two patterns of list comprehensions. Sorry for the change in screen sharing here. It takes a little bit of time to jump over to the right screen. And so if you have any questions while I'm going through this, please put them in the chat, because since there is a little bit of a delay, by the time, I don't want to move on to something else before we get a chance to answer your question. Okay, so one thing we can use a list comprehension for is using the range function to make a list that has a whole bunch of numbers in it, a whole bunch of zeros or starting values. And we'll use a range a couple times in the exercises today. Basically range, I'm in Python 3 here, so I have to convert this to a list. In Python 2, this would work with just range. It gives you a range of numbers, 0 to 9, if we give it 10 there. Let's use a list comprehension for a little bit more complex example. Okay, so here we have a range from 1 to 10 inclusive, and we're looping over each of those values and returning a tuple x squared. So the first value is the original number, and the second value is the square of that number. So with list comprehensions, that x for x in, or x squared for x in, it can be any expression basically that you can think of that you would put in that append in the original for loop. And in fact, the looping, as we can see here with range, can be any expression that you can think of that gives us something we can iterate over. It doesn't just need to be a list. It doesn't just need to be a variable name. And we'll see in a little bit that this x here can actually be a little bit more complicated as well. So just to reiterate that, we can call functions or methods inside that first part there. So color.upper here should loop over colors. Oops, I forgot to define colors. So if we have a list of colors, we can loop over those and convert them all to uppercase. And that'll give us a whole bunch of capitalized colors there. So color.upper is an expression. Remember that that first part can be an expression and that last part can be an expression. And that part in the middle, we can do some extra things with it as well. All right. Let's jump to another example here. So I showed you very briefly there in the visual example in the Google Drive sheet that was linked that you can have a conditional. So let's say we have a list of cubes, or let's say we want a list of cubes of all of the perfect squares up through 100. So this is a really mathy kind of thing to ask for here, but it's okay. You don't know what that means. I think it'll be clear. We make it. So we have all the numbers from 1 to 100. We can get all of the cubes of those numbers like this. So we've taken every number and we've cubed it. Now, what if we want to get the cubes of only numbers that are perfect squares? A perfect square is a number that if you took the square root of it, it is a whole number. So 25 is a perfect square because 5 is the square root, 24 isn't. So we can add an if clause here. I'm going to clear this and bump it up here so you can see it. And we could say x, let's get the square root function. So this is a neat little trick here that you might not have seen before. If you take the square root of something and then ask it if it's an integer, that'll tell you if it's a perfect square. So you can ask floating point numbers in Python if they're integers. You can ask any number if it's an integer. That's a good point. So the Google Drive link was linked at the bottom of the exercises. Let me add a direct link to that in the chat as well. Okay, so hopefully this gives us the cubes of all perfect squares. And it does. Okay, so what this would look like as a for loop. Oops. I forgot to make a list to put these in. Let's start that over. So that's quite a bit longer. We have 1, 2, 3, 4 lines of code there that we're condensing into one. Now, that one line of code, sometimes when you're writing a list comprehension, they can get really long. That doesn't necessarily mean it's less readable. It does mean that you might want to figure out a way to space it out and figure out whether you can make it more readable. So in Python, oops, where did my mouse go? In Python, we could take this list comprehension here, cubes of squares, and we could rewrite this like so. So Python knows that when we hit the enter key here, because we have those open brackets, it's still waiting for us to continue typing things. So whenever we type things inside parentheses or inside open square brackets or inside open curly braces, it knows that there's more to come. And so it's waiting for us to finish that so we can break those lines out line by line like this. Now this doesn't look that much different from that for loop we saw, but I do think it makes a little bit more clear what your intent is, that you're making a list right from the beginning. You're making a list, you're going to populate it from values of this other list. And this is something that can take a little bit of time to get used to, but many would argue this might be the more Pythonic way to write this code. It's definitely a debatable subject, though, what exactly is Pythonic. Okay, let's take a look at a couple other examples. Actually, first, let's jump into an exercise. So those exercises I linked there, let's go to that page. I'm going to open it up here too. And let's solve one of these together. Unfortunately, since there's a 15-second delay, this will probably be a little bit more of me solving it than you, but I'm going to compensate for that by going in, getting some more tea, and waiting for you to type some things in the chat, maybe a way we could brainstorm to solve this. So I'll be right back. All right. So I want to show you a solution for this first one here, and then maybe we can take a break to do some exercises for 5 or 10 minutes here. There's 1, 2, 3, 4, 5, 6 exercises in here. I like to do exercises during the teaching so that we kind of get a chance to apply the thing we just learned before we move on. And we're going to move past list comprehensions to set dictionary comprehensions and generator expressions. So if you would like to take a break for 10 minutes and do some exercises, that would be great. If you think maybe we should, well, yeah, let's do some exercises first, and we can see how it goes the first time here and see whether we want to take a break the next time. First, I want to solve this first one along with you. So hopefully you've had a little bit of time to think about power list by index. If not, that's okay. There's a couple others. This first one's a little bit trickier because it's using a function that we haven't seen here before, at least not today, and you may not have seen it before. It's enumerate. Let me show you how that works here. Okay, so if we have a list of numbers and the question asks us to raise them to the ith power where I is the index of the number in the given list. So the index of the number in the given list, this is the tricky part here. If we use enumerate, this is a function that loops over every item in a list or any kind of iterable thing that we give it, anything you can iterate over, and it takes every value of that and gives us back a tuple of the index as the first argument and the value as the second argument. So the index of the first thing is 0. The index of the last thing is 4 because this list is 5 elements long. And the values of these are 1, 2, 3, 4, and 5. So it's giving us this list of tuples here. So that's a way we can get the index out of this. Now, how do we raise it to the ith power where I is that index? Oops, typing in the wrong window here. So if we would write this as a for loop, we could say for in numbers. So we can actually do tuple unpacking in that for loop, which means we're taking each of the values and unpacking them into the first one and the second one, and it has to have exactly 2. Fortunately for us, we have exactly 2 values in each of these tuples. Here we're raising n to the ith power. Oops, and sticking it into powers. Oops, I see. I forgot to use enumerate here. So we were looping over the numbers and trying to unpack each number into I and n, and it was not happy with that. Okay, so that looks like it's probably right. I'm not the greatest at math, but those seem like they're probably powers. So this for loop here, we can just rewrite this as in I for I comma n in numbers. And we know that we can do this because we have gotten this in the format of, and this is in that Google Drive that, file that I'm looking at right now. We've gotten this in the format of a for loop. For something in something. Something.append something. So we have to take all those somethings, look at the color coding in that Google Drive cheat sheet there, and rearrange them to stick inside our list comprehension all in one line there. And it kind of reads like English when you're done with it. It's a little bit odd at first, but we're basically saying here, n raised to the ith power for every I and n in, and actually I just noticed a bug here, I forgot enumerate again, in enumerate numbers. So that gives us the same values there. Okay, so it's been about 5 minutes. Let's take another 5 minutes here for exercises, and I'm going to see how we're doing on time. And feel free to, if you're stuck on any of them, want some particular help on one of the exercises, think maybe you have a solution and don't know if it's right, stick it in the little chat there. I'm going to screen share the cheat sheet here so you can look at it easily while you're working through those. So I can figure out how to get over to it. So I'll scroll down to the one that's got the if statement. If you think you've got a solution for one of them, feel free to post it in the paste bin and stick a link right into the chat here so we can all see the way that you solved it. Have I been on mute this whole time? I think I have been. Okay, so I apologize. I was typing that in there without any explanation in the screen share. So basically, there's a couple ways to solve the same problem sometimes here. And I'm going to look at your paste bins. Oh, I like that one. Okay, I meant to be on mute for a minute or so, but I think I was talking for about a minute without realizing that I was on mute. So I'm going to start that over. Fortunately, that gave you a little bit extra time to do the exercises. So let's look at a couple of these answers. Paste in a couple of these. And I'm putting a couple of my own in here as well. Right, so let's take a look at vowel names real quick. So one way to solve this is to take the first index, or the first element in the name that's given in for each of the names that's given to our function, and check to see whether it's in a list of all the vowels. Now, the question was vague. It didn't specify whether we cared if they were uppercase or lowercase. Probably names start with an uppercase letter, so that's a pretty good assumption. So I think a lot of these answers are probably going to reflect that as well. So the reason we see this name for name here in pretty much all of these answers is that we're only filtering this list. We're not changing every value in the list. So whenever you're filtering a list with a list comprehension, you're going to see this odd X for X or name for name, because the if part is the only thing we really care about in this particular list comprehension. Other paste bins to see if they're on the first one. All right, so another way to solve this, well, actually pretty much the same way here, but kind of cleaned up a little bit, is, oops, I apologize, I don't remember who pasted all these in the chat. I put them in here without names, but vowel names, sticking that list before our function, or actually even really inside our function. Either of these would be maybe a little bit of a readability improvement, because we're saying we're checking to see if the name is a vowel, is in vowels. And that's a little bit more verbose and descriptive. We're kind of making our code a little bit more self-documenting there. Another way to do this, regardless of whether we put that variable here or not, we can do the same thing here, is to make the list of vowels actually a string of vowels. So what happens when you iterate over a string in Python is it gives you back new strings with just one character in them. So it's kind of a bit of a trick there. It's a little bit more terse, a little bit less verbose there. And I'm not sure if it's more or less clear necessarily. So I could go one way or the other on that. Either of those solutions is equally valid. Yes, you are supposed to see what I'm typing. I'm sorry. Diane just pointed out that I have been not screen sharing this whole time. All right, so I'll give you a moment to take that in here. This first solution uses a list. This second solution uses a list, but we're sticking it inside a variable to make our code a little bit more self-documenting there. And the third one, we're sticking, instead of a list, we're using a string. So we're looping over all the characters in that string, getting new strings out of them. And fourth and fifth ones here, we're assuming that maybe the question was too vague and the names might be lowercase or uppercase. And so we're either uppercasing them or lowercasing them. I'm going to look at the other paste bins here real quick. Okay. Let's move on to generator expressions now. And at the end, we'll go over generator expressions and then set comprehensions and dictionary comprehensions. And then at the very end, there's some more exercises that are in that document that are a little bit more advanced that go over those topics. And we'll just do those until we end here. Okay, so let's start with our list of numbers again, 1 through 4. We can sum up these numbers by using the built-in sum function in Python. That's kind of nifty. Now, what if we wanted to sum up the square of each of these numbers? We wanted to take each one of them, square it, and then add that up. Sort of like maybe a Pythagorean theorem kind of thing. We could do this. So we could take a list comprehension, and instead of assigning it to a variable, we could just stick it right into our function call. Now, that works, but there's a little bit more elegant way to do this. So first, let's go over the fact that sum doesn't actually just take a list. It takes anything that you can iterate over. So here we're giving it a tuple of 8, 9, 7, and it's summing those up. We could give it a set or any other thing that we can iterate over and it can get values from and then add those together. So there's something similar to a list comprehension in Python, but it doesn't actually give us a list. It gives us sort of a promise that it can loop over those things and give us back the list or the iterable that we're expecting as we loop over it. So it's kind of lazy. This is called lazy evaluation. A lot of programming languages have constructs like this. This is one of those cases in Python. So squares here, notice we're using parentheses, not square brackets. This is a generator object. This thing doesn't actually, we can't get indexes from it because it's not subscriptable. It doesn't actually have anything in it really until we iterate over it. So we can iterate over it by using it in a for loop or converting it to a list or a couple other things. Right here, we're just going to convert it to a list. So now we get the squares back. So we could take this generator expression and we could actually use it in our sum function call. Now the reason for this, the reason that we have this idea here to use this generator expression and we have this ability in sum is that we don't actually need the squares in a list every time we call sum. So sum only needs to be able to iterate over things. And let's imagine that this list of numbers is millions of numbers long. You know, it's the range up to there. Unfortunately, this isn't actually going to do anything on my computer, otherwise it would probably crash it. But if we were to iterate over that, take the squares of each of those numbers and then sum them up, we don't necessarily need it to be an entire list of millions of numbers, making 2 of those in memory. So we can use a generator expression for this. Now, the way that would work is to stick that expression right in sum. Oops, that was almost bad. I was trying to sum all of the numbers up to, I don't know what that is, 1 billion. Okay, so this works. We can sum up our numbers using a generator expression. Now, Python actually has a shortened syntax. We can remove the inner parentheses here whenever our generator expression is inside some other parentheses. When exactly that is not always clear. Basically, the rule of thumb that I tend to use is if it's directly inside two parentheses, you can remove the parentheses on the outside. So this works just the same. So we're only losing 2 characters here, but I find it's a little bit more readable and it's a little bit more performant. And yes, generated expressions and generators are in Python 2 and in Python 3. I think they were added in somewhere back before Python 2.7, so maybe it's not as relevant now. Okay, so you'll see generated expressions often whenever you need an iterable, but you're going to consume it immediately. You're not going to use it as a list. You're going to just throw it into something, and it's going to iterate over it and do some action based on that. Sum is a good example of that. Here's a couple other functions that this is useful for as well. We have our numbers. There's a min function. You can find the minimum of our numbers, or minimum of our squared numbers. Max works the same way. And here's 2 that are a little bit trickier, any and all. So any and all, whenever they get something that's truthy, any returns true if any of the things in this iterable are true. And it returns right after the first one. So you wouldn't want to make a whole list if you only need, if maybe the first value is true out of millions. It's much faster to use a generated expression in some cases for any. Okay, so this is true here because 3 and 4 are greater than 2. It's not true because none of them are greater than 5. We can say all, and all returns true if every single one of the values in there meets this little predicate here, or makes this thing true or truthy. Okay, so now that we've gone over generated expressions, that's a little bit more, that's probably the most advanced of the things we're doing here, because generators are a little bit of an advanced concept. But basically just know that whenever you see something that looks like a list comprehension but doesn't have the square brackets, that's a generator expression. Now let's jump into set and dictionary comprehensions. And if I'm having any other trouble with the screen sharing or the audio, let me know. I unfortunately can't see myself and hear myself while I'm doing this, so please just shout out if there's any trouble. All right, let's say we have a list of words and we want to get the first letter of all of our words, but we want to get them uniquely. So for example, if lime and lemon are in our list here, we only want to get L once. We don't really care about the order of these. We only care whether or not a letter appears as the first letter in our words. That's a great question. I should have paused before we jumped into this. Before we get deeper into set and dictionary comprehensions, I'll explain why generators are useful. So generators, the last time I taught a session like this where we talked about list comprehensions and generated expressions, I crashed my computer by making a list that had lots of numbers in it and trying to do something with it to demonstrate how slow it was. So I'm not going to try to do that on the fly, but basically, if you have a list of things, you have something you're going to iterate over, a list comprehension generates an entire list out of that thing that you're iterating over, an entire new list, and then does something with it. If you only need one thing at a time, for example, like sum, you only need the first one, and then you know you're going to add it to something. Then you get the second one, you add the 2, and you store that new value. You don't care what the old ones were. You get the third one, you add that to that new value, you store that, you throw out those 3 before. So you only need it piece by piece, each value at a time. Anything that you can do that kind of operation on, a generator is good for, or a generator expression, which is an extension of generators. Generators, I would say, are a little bit more advanced than generator expressions, only because they're not, they're a little bit further removed in terms of how they visibly look when you make them. There's yield statements instead of return statements often, and it's a little bit harder, at least for my mind, to understand them. Whereas a generator expression is basically a list comprehension with those brackets removed and parentheses put in there instead. And thank you for jumping into the chat there, Camilla, and whoever else is jumping in there as well to explain generators and generator expressions. Feel free, if you do see a link online that explains a little bit better than I just did, to stick it right into the chat there. Okay, so we could use a generator expression to create a set out of those first letters that we were saying, we were talking about before. So we could use a list comprehension, or we could remove those square brackets and use a generator expression. So this will make a new set of all the first letters of these words. So we only have L once because this is a set, and so it deduplicates. Whenever we add something to a set that's already in there, it just ignores it and moves on. Now that's a pretty elegant syntax. We have set and then the thing that we're making there, but there's actually a shorter syntax that Python has now. And this is as of, I think, Python 2.7 or maybe even 2.6. So this should be in all of your Python interpreters here. So this should look a little bit familiar. This is basically like a list comprehension, except instead of denoting that it's a list by using square brackets, I'll show you what that would do here, where we have two L's, we're using curly braces to denote that it's a set, because that's the way that we can make sets. So if we were to make a little set that had some letters in it, we use curly braces to denote those. So set comprehensions are fairly easy to understand if you know list comprehensions and generator expressions. Once you've understood one of those, the three kind of go together fairly easily there. They're kind of logical extensions. A little bit more difficult is dictionary comprehensions, but I want to pause for a moment and ask if there's any questions about set comprehensions and generator expressions, and I use this as just a moment to relax as I wait for 15 seconds here for maybe some answers to come in. All right, I'm going to start typing out my dictionary comprehensions here, but you know, don't be afraid to keep typing in questions there for set comprehensions. I know there's a little bit of a delay here. All right, so let's say we have a dictionary where each of the keys is a name and each of the values is maybe that person's favorite number. So the dict constructor allows us to pass in, let me show this real quick, a list of tuples or any iterable we have, anything we can iterate over that gives us tuples back. So here we're making a dictionary from 1, 2, 3, 4, 5, 6. The first thing is the key, the second thing is the value. So the keys are 1, 3, and 5, and the respective values are 2, 4, and 6. So if we were to take our dictionary here, and maybe we wanted to filter it, sorry, I have to scroll down in the chat here. Unfortunately, this Talk.io website doesn't auto-scroll, so sometimes I miss your messages. If we wanted to take this dictionary and produce a new dictionary that only had favorite numbers that were less than 100, maybe we needed 2-digit favorite numbers today, we could do that by taking kv for kv in favorite numbers.items. Items is a method on dictionaries that gives us keys and values in this kind of list format, similar to what we just saw up above from our dictionary. And then we can say if v is less than 100. So this should give us a new dictionary where all of the values are less than 100. Okay, so it looks like we have favorite numbers from Dorothy, Harold, and Ronald, but not Rebecca because her favorite number was 3 digits, and so she's not in this new dictionary here. So this works, and this is fairly descriptive, same way that our set example is fairly descriptive, but there's a shorter syntax. And let me pause real quick and check the chat. Thank you for explaining sets there. So these are a little bit more advanced examples that we're looking at here, but sets, you probably don't see them very much in Python unless you're doing a lot of math or a lot of things with set computations, but they basically ignore uniques, or they are unique, they ignore duplicates. So whenever you add something to a set, it won't allow duplicate values, it just removes them, and they're also not ordered, which is a big thing. Just like mathematical sets, they have no particular order to them, similar to the way dictionaries are not ordered. And I'll put a link to some set documentation in there, or if someone else wants to find some that's particularly helpful, I'd appreciate it. So back to our dictionary example here, Python has a shorter syntax for us. We're using a generator expression here, and we're taking these key value pairs, and we're making a new dictionary out of them. We can actually do this, though. We can use curly braces and say k:\v for kv in favorite numbers.items if v is less than 100. And this gives us the same thing. So this syntax, it's not drastically shorter, but it's a little bit more of a difference than that set syntax that we saw there, because we've got this k:\v, and sometimes this can be a little bit hard to read. I don't know about this example here. I think this one might be okay, but often you'll see the same thing we did in that other example before, done with dictionary comprehensions to make them a little bit more readable. k:\v for kv and favorite numbers. So you can break it over multiple lines here. Okay, so let's look at another example. Let's create a dictionary where the keys are letters and the values are the indices of those letters in the alphabet. This is kind of a fun thing. So if you ever did secret codes or hide messages, maybe Caesar ciphers, basically this is kind of like that. We're taking the letter A, we're getting number 1 from it, we're taking the letter Z, and we're getting 26. And actually, I think we might start indexing at 0 there, so maybe it's 0 and 25 instead. Okay, so if we were to do this as a for loop, it's sometimes easier to think of things in a for loop and then erase your work and start over with a list comprehension. Or actually, let me show how you can copy paste your work and change it to a list comprehension. Oops. So if we just wanted to get the letters here, we could do it this way. Now, if we want to get the index of each of these letters, and let me just show real quick that ASCII lowercase, this is just a shorthand for me not typing in all these letters. In the string module, there's an ASCII lowercase value. It just contains all the letters of the alphabet. So if we use our enumerate function, we should get an index and a letter back for each of these letters. If we start a new dictionary here, we could call it letters. Maybe that's not a good name, but we'll go with it for now. The keys are going to be the letters, and the values are going to be the place where they appear in the alphabet, starting at 0, ending at 25. Actually, let's start with 1. Let's see if the code works. Ooh, okay, so dictionaries are unordered, so it's a little bit hard for me to see what's going on. A is 1, I think T is supposed to be 20. Yeah, this looks like it works to me. Okay, so we can take our for loop here, and we can make this into a list comprehension using our cheat sheet that we saw before, consulting Google Drive. Unfortunately, I can't bring them up at the same time, but you can bring that up on your own. This is the part that was in purple here, and we can take this purple section and make it into letters, and we'll do dict, and let's just do a list comprehension for now to keep it a little bit simpler. Key is going to be letter, and at the bottom of that Google Drive file, there's actually an example for dictionary comprehensions. The value is going to be number, so letter, comma the number 4, and actually let's just copy it all from here. So when converting a for loop into a list comprehension, a set comprehension, a dictionary comprehension, you can usually just copy paste this whole for line and stick it straight in there. That's what we expect. So we're looping over enumerate of the letters, enumerating the letters, we're looping over those, getting I in the letter, and then making key value pairs from it. Yep, looks like it works. All right, let's make this first into a generator expression here. And then we'll remove this and start to make it into a dict comprehension. Now, dict comprehension's a little bit different. They don't want tuples. They want key value pairs with that colon in between. Actually, let's make this a little bit more readable. Don't be afraid of using too many parentheses. You can always remove them. And there we go. Okay, so we have some exercises now. I want to solve this first exercise along with you the same way I did last time. I'll give you a moment to bring up the exercises there. I'm going to post a link in the chat as well. So the first exercise, this is under the more comprehension section. It's called ASCII strings. And it asks us to create a function that accepts a list of strings Can you see me now? Unfortunately, I'm going to have to wait a little bit for people to see if they can see me. So I lost the feed at some point. I guess Hangouts only allows an hour. We'll see what happens when I restart this. Hopefully it doesn't overwrite the original video. It just depends on to the end. Looks like so far no one can see me. Ah, you can see me. Excellent. So I guess everyone's on the same page because everyone chimed in at once. I should have timed how long that delay was. I'll have to try this out later to see what happens with the delay. Okay, so let me figure out where my screen is and get back to screen sharing. Let me know if you can try to describe where I was. I'll check the Hangout in just a bit to make sure I backpedal to where I was. Otherwise, I'll just keep moving forward and try to take a guess at where I was. Yeah, there's a lot of delay. So our example here in our exercise, our first exercise, we have our words, and there are a list of words here, and we want to get the ASCII character codes of each of these letters. So the ASCII code of capital letter A, I think, is 65, and lowercase letter a is 97. Those are really the only ones I remember, because if you really needed to, you were lost on a desert island, you could figure out the other ones by using some math. Let me look up how to do that. All right, let me look up how to actually get these. So I think it's the ORD. ORD, yes, ORD is a built-in. So if we pass A to it, it gives us 65. That's a capital. Lowercase a is 97. Starting in the more comprehension exercises, great. Okay, so we should be able to use this ORD function to get the ASCII character code for each of our letters. And I'm actually curious. I'm going to see what happens when I put an emoji character into here. Oops, I lost my window. Ooh, all right, it gives us something. That's cool. Let's solve this using ORD. So get ASCII codes. We're going to write a function. And for each of our words in this function, like a dictionary here. The word is going to be the key. The value is going to be some kind of list. Now we could use a for loop inside a for loop, or we could use a list comprehension here. So we could say, the thing we're looping over is C, that's a character. We could say car for car in word. And then we need to do something with it. Car for car in word. We'll take ORD of that. So ORD of a character should give us the ASCII value for each character in our word. And let's return this. Let's see if this basic function works here. Go back to here and paste this list in. There's hello, there's Python, there's bye, there's yes. That looks like it's working. So we have a single list comprehension here, but we actually have something that looks kind of like a thing that we could refactor into a list comprehension. If we check our cheat sheet, we'll see at the bottom of it, there is a dictionary comprehension example. So this is the purple part here, our for. This is the dictionary that we're starting to make, the name of that dictionary, the key that we're adding, and the value that we're adding. Let's try to rewrite those 3 lines above. It's a dictionary comprehension. Word is the key. This is the value. And then we can just copy this for part. Wow, there's a lot going on there. So this is a little bit complicated. Actually, we can just return this whole thing. Let's break this up over multiple lines. I think that might make it a little bit more readable. Okay, so word is the key. Word car for car in word is the value. And for word in words is our looping. Oops. It's broke. Not sure what's going on there. There we go. See if that works. It looks like it gave us the same answer. So I'm going to check the chat real quick, but ponder this for a moment. I would argue this is actually a little bit more readable than, let's look at our alternative here. So our alternative is use a single list comprehension. So here it is with one list comprehension. Here it is with a dictionary comprehension with a list comprehension inside it. Feel free to state an opinion to say which one you think is more readable. It's maybe a little bit debatable. I prefer the second one personally. Now let's work through the rest of the exercises here. So I don't have anything else in particular planned for the rest of the time. So we've got our more comprehensions exercises and the ones that we didn't solve before. And then feel free to just jump in the chat and keep chatting. And I'll leave the video running. I assume this part will still go onto YouTube even though we lost it. And unfortunately, since there's a bit of a delay, I think I'm going to just go a little bit silent on the video for now and jump into the chat and ask anyone if they have questions there. And then I'll jump back into the video if I'm answering questions that maybe need a little bit more explanation. I'm going to bring up 2 things here. I'm going to try to screen share at the same time. The exercises and the cheat sheet. Google Hangouts is a little bit tricky to use with 2 monitors. You can find a link to this sheet here, as well as the, it's actually a gist on GitHub that links to this sheet. As well as the exercises at this URL here that's shown in the video. Make it a little bigger. All right, I'm saying this in the chat as well, but if there's any particular exercise you'd like to see a solution to, just type it into the chat. Maybe there's something you're stuck on, or a solution that you solved it one way, but you're wondering if maybe there's another way to solve it. Okay, so one of the exercises is a little bit more advanced. It's on flattening a matrix. So there's a couple ways we could do this. The first way the first way actually we already know about. We could use a for loop with another for loop inside it and convert that to a for loop with a list comprehension inside it. The second way is actually to use a nested list comprehension, and that's something we didn't actually go over, so I'm going to review that really quickly right now. Let me change my screen share here. Okay, so our matrix, I'm just going to copy paste this in here. Oops. That's our matrix. So we've got 4 rows and 3 columns. Now we want a function flatten that flattens this matrix. So what a flattened matrix would look like is a flattened version of this matrix. Look like this. We take the first row 1, 2, 3, the second row 4, 5, 6, and all the rest, and just kind of string all the values together. Okay, let's make a list flattened. And then we'll say for row in matrix. And then in a row, there's value. So we can say for value in row, flattened append value. Of the chat to make sure everyone can hear me okay. All right, let's see if this works. Basically, we have 2 loops here by necessity because we've got rows we have to loop over, and then within each of those we have values that we're looping over. And appending that to our flattened list. Let's call flatten with our matrix. All right, so that gives us what we were looking for there. Let's rewrite this to use first one list comprehension. Actually, how could we do the one list comprehension? I guess we could do it like this. So I think it's extend, flattened.extend. I'm going to look this up in the help real quick. I usually go to Google for documentation, but it works too. Extend list by appending elements from the iterable. So we can call extend with another list. Call it with value for value in row. Wait, actually, we could just call it with row, now that I think about it. See if that works. Oops. Keep pressing the wrong keyboard shortcut and jump into another window on my screen. Okay, so that works. Now, a shorthand for extend that I prefer is actually plus equals. That works too. Okay, so this is a little better here. We're not actually using a comprehension, though, at this point. I think the only way I can think of to do this, actually, is to use a nested comprehension. I said before that we could use a for loop with a comprehension inside it. That might be true, but I can't think of how to do that off the top of my head. So instead, I'm just going to go all the way here. So how a nested comprehension works, I'm going to put this back to the for loop, the nested for loop we were in before. And this is something that I didn't understand until recently, or rather, I didn't think about it in my head this way until recently. It really helped out when I did. We can copy value here, which we already know. And then let me make sure I'm still screen sharing on Hangouts. I just got paranoid. Yes, I am. Okay. We can take the value here and then say we want our for section here. Now the order, we're going to do two for loops inside here. We're going to say value for row and matrix for value in row. This is going to loop twice. So the reason the for loops are in this order is that we do the outer one first, and then the inner ones inside that. So it's this, these appear in the same order they would appear if you were writing this out as a nested for loop. Once I understood that, it made it a lot clearer in my head that this order is the same way it appears with the for loop, because I always really wanted to write it this way when I was writing a nested list comprehension, and I'd usually avoid nested list comprehensions because of this. For value in row, for row and matrix, to me that's a little bit more similar to English, and it made a little bit more sense. But Python wants it this way: value for row and matrix for value in row, and it's only going to work that way. So let's try this out. And that works. So let's try flipping this the other way and just make sure that it doesn't work. Let's see what Python does. And I have to remember what it will do. I just know that it's yelled at me before when I did this. Oops, invalid syntax. Value for row and matrix. Name row is not defined. So value for value in row, it doesn't like that because it hasn't defined row yet, because it loops over, or it executes these little for statements in the order they appear. So we kind of have to write it in this sort of almost reverse notation. At least in my mind, it's a bit of a reverse notation. So that's the way that we can solve flatten using a nested list comprehension. All right, I think we've seen answers for all of the exercises here. Actually, I don't know if we've seen filter and map. If you'd like to see answers for any particular exercise, or want to see me walk through them, or we can walk through them together, feel free to put the names of those in the chat there. Otherwise, we're pretty much done here. We can continue chatting in the chat there if you have any questions, or call it a wrap. I'll kind of pause here to wait for answers for another minute or so. Probably just be a minute of silence on the video. So I apologize for that for those watching on YouTube afterwards. So it looks like we're wrapping it up here. I'll keep chatting online in the chat room there, but I'm going to stop the video. If you want some more information on Python things, I'm thinking of starting up a Python mailing list soon, probably in January. You'll be able to find it on my blog once I do, or on my Twitter. I'll make some announcements. I do have a mailing list right now, but it's just sort of a more general newsletter. It's not very Python oriented. And I do plan to do some webinars in the future. I don't know in what form. Hopefully they won't have as many technical difficulties as the one that we just did. So see you all next time and on the internet. Bye.